basic about the wood chemistry. শুনতে পাচ্ছ আমার কথা?
জি স্যার।
So we will just start the class. So the first chapter that deals with the structure of the wood. So that we have discussed a bit in the earlier classes. So the structure of wood actually it four different levels of structure we just think. The first thing of the first part, the first level we will see that is the macro structure. That is very big structure like growth ring. You can see it, the fiber length, even 2 millimeter. You can see it. So that we are saying macro structure. The color, the other things that we say that we can see, and we are saying that is the macro structure. In some cases, then the next level that we are saying microstructure that we cannot see in naked eyes. So we are saying that is the microstructure, and that is in micrometer. So macrostructure that is in meter, millimeter. So if we say bowl, that is a macrostructure, but bowl that is the properties of the tree, not the wood, but we are talking about the properties or structure of the wood. So just think the color that we can see, but that is not the part of the structure. So we will talk about the structure. It means like the grain orientation that we can see. So that we will say macro structure, and if that macro structure is in meter or millimeter level, then we will say that is the macro structure. In case of microstructure, we cannot see by naked eyes, and that is the in micrometer scale. Then ultra structure, that structure actually you not have so far studied ultra structure. You have studied a bit. So that is you can see only by electron microscope or even further better things like same TEM. So you need to use that so that you can see that ultra structure. That is definitely in nano structure, nano scale. So we can see that the macro structure that is in meter and millimeter scale, the microstructure that is micrometer scale, and ultra structure that is nanometer scale. And finally, we are saying supra or molecular structure. Definitely, molecular it means that is in tens of the nanometer. So even smaller than that is still in the nanometer scale, but on tens of the nanometer. So that is our target in this course to go for the molecular structure. So molecular structure we will study so that when we say molecular structure, it means definitely that deals with the chemistry. So in this course, our target is to study the molecular structure of the wood so that we will know the details properties like earlier courses, wood structure and properties. Mostly we have discussed the macro structure. A bit microstructure also we have discussed, but never we discussed about the ultra structure or molecular structure. But in this course, our target is to go for the molecular structure. So the very small particles we will understand and how they make join together, and the wood gives us huge strength. So how it comes, that we will study from when we know the molecular structure, then we will know about it. So this is the tree. You can see this is a tree. So definitely this is a broadleaf, right? Do you agree? Or conifer? Is it broadleaf or conifer?
Broadly.
Sir, broadly.
Okay. So definitely that is a broadleaf tree. What about the tree? That is a tree if we think. So we can say that is a macro structure. Then we can see the trunk of the tree, and it has cambium, it has sapwood, it has hardwood, it has inner bark, outer bark. Even if we go forward, we can say there is early wood, there is late wood. Then we can see some other structure also. So definitely that is also macro structure. Then if we go further, we will see there is early wood, late wood, hardwood, sapwood that we can say. That is the growth ring we can say, we can very clearly visible that early wood and late wood. So up to that, we can say macro structures from tree to that growth ring, or even further, we can say in some cases like the length of the fiber, that we will say that is the macro structure, because we can see the fiber, the pulp we can see, pulp is the individual fiber, so we can see the fiber. So definitely that is a macro structure. Now sometimes we can see there is some core, but that is very clearly we cannot see. If we have some lens, magnifying lens, then we can see some of the structure like that. So we are saying that is the microstructure, because the macrostructure we can see in naked eyes, but in case of microstructure we may not see in naked eyes. So we will say that is the microstructure. After that, there is ultra structure. So ultra, you can never see the uh, different layers of the cell wall, like middle lamella, primary wall, secondary wall, layer. You cannot see. So that is definitely ultra structure, and that ultra structure in the structure and properties you have studied a bit, because you know different layers of the cell wall, like secondary wall is again divided into three different sub layers, S1, S2, and S3, that you have studied earlier. So ultra structure, some part you have studied even earlier. Then microfibril. Also in that course, you have heard about the microfibril. So that is the combination of several, what we can say, cellular chain, so that you have some idea about the microfibril, then macrofibril, then some of the that things you know. So you have studied a bit about that nano scale also, but not in detail. But in this course, definitely that three different structure: ultra structure, microfibril, that means ultra structure, uh, and also the suprastructure, that we have studied detail about that, because the macro structure and microstructure that you have studied earlier very clearly, but the ultra structure you have studied a bit, both microfibril and also the different layers of the cell, so that you have studied a bit. However, the details we will study now, and also the suprastructure, that is our target actually. So before going to that target, we will also study that ultra structure. So this is the tree, and that we have studied. It has different. At the center, we are saying that is the peak. So if this is a tree, we can see the top part, the branches, and also the leaves. We are saying the crown, and the crown. Uh, the bottom part of that crown, or below that crown, there is a trunk. And if we look at, if we cut something into the trunk, we will see at the center there is a pith. There is spring wood, summer wood, we can say early wood, late wood, whatever we can say. And just below the uh, outer bark, inner bark, that means the phloem, there is on thin layer, softer layer, we will say that is the cambium. And after cambium, there is xylem. That xylem is divided into what we can say, that xylem is divided into heartwood and sapwood. So sapwood is the outer periphery and heartwood is the inner periphery. Sapwood is the living cell, and heartwood is the dead cell. So that we have studied earlier. Then different types of cell types also in the wood. So there is resin canal. Resin canal, it means some of the liquid that flows through that mostly we can say that is just like adhesives that present in the wood. So at the liquid condition, that is the latex, we can say. uh, there is also some other cells like trachite, like ray cell. So ray cell, that is just only horizontal cells. Trachite, that is definitely vertically oriented cell. Then parenchyma cell, that is also vertically oriented cell. Only the ray cells, that is horizontally oriented, but all other cells, those are the vertically oriented cell. And also we know that if we go for the we make a piece of the wood, we'll see there is three different surfaces on its cross section. So from the cross section, we can see the lumens, and there is radial, and there is tangential. So if this is the hardwood cell, so we can see the fibers. In case of softwood, that is the trachite, that is the main cell. Around 90% of that, that is the trachite. And in case of fiber, that is the part of the hardwood cell, and that is around 85%. So in case of hardwood, there is also trachite, but that is smaller, and the percentage of that trachite just only 2, 3, 4, 5%, not more than that. But that trachite, in case of softwood, that is around 90% is trachite. Then both softwood and hardwood, it has parenchyma cells, and that is the vertically oriented cell. Also there is ray cells, that is the horizontally oriented cells. So all these things are almost similar. However, in some cases you will see in case of hardwood, some of the lumens that is bigger. So we say that is the vessel element. We will say the very big holes are there. We will say that is the vessel, but that you will not find in the softwood. So the things what I have discussed earlier, the trachite, that is around 90% in case of softwood, and in case of fiber that is the main cell of the hardwood, and that is around 75%, and all other cells besides that there is some other cells. So all these things that we have discussed so far, so that is related with the macro and micro structure. So if you have any question, you can go for it, because we will change the slide and we will go for the next one. So anybody, any questions?
স্যার আলট্রাস্ট্রাকচারে দুটো ওয়ার্ড ছিল এসিএম আর টিইএম, এই দুটার মানে বুঝি নাই স্যার।
স্ক্যানিং ইলেকট্রন মাইক্রোস্কোপ, সো যেটা দুই ধরনের মাইক্রোস্কোপ। জাস্ট কিছুই না, তোমরা সেম নাম শুনো নাই কখনো? স্ক্যানিং ইলেকট্রন মাইক্রোস্কোপের নাম শুনছো? আমরা অনেক ছোট জিনিস দেখতে চাই, নাম শোনো নাই কখনো?
জি স্যার।
জি স্যার।
তো এটা দুই ধরনের মাইক্রোস্কোপ। আরেকটা হলো ট্রান্সমিশন ইলেকট্রন মাইক্রোস্কোপ। একটা স্ক্যানিং ইলেকট্রন, সেটা শুধু সারফেস, তোমাকে সারফেসের পিকচার তুলে, মাইক্রোস্কোপ তো জেনারেলি সারফেসের পিকচার তুলে, তো সেটাকে আমরা স্ক্যানিং ইলেকট্রন মাইক্রোস্কোপ বলতেছি। আরেকটা ট্রান্সমিশন ইলেকট্রন মাইক্রোস্কোপ, যেখানে কিছুটা লাইট পেনিট্রেট করে সার্কুলার ভিতরে, তো সেটাকে আমরা ট্রান্সমিশন ইলেকট্রন। সো আগে সেম, দেন টেম পরে, মানে টেম হলো মোর অ্যাডভান্স স্টেজ। আমার কথা কি ক্লিয়ার হয়েছে তোমাদের কাছে?
জি স্যার।
আর কোনো কোশ্চেন কারো? আর কারো কোনো কোশ্চেন আছে? সো তোমরা কি বলতে পারবা যে মাইক্রোফিব্রিল কি?
combination of cellulose chain.
মাইক্রোফিব্রিল
Combination of cellulose chain.
কম্বিনেশন অফ সেলুলোজ চেইন, এই কথাটার মানে কি? তোমরা পড়ো নাই উড স্ট্রাকচার এন্ড প্রপার্টিজ এ মাইক্রোফিব্রিল? একটা সেলের
স্যার সেল ওয়ালের গাঠনিক একক।
তোমরা কি দেখতে পাচ্ছ স্লাইড?
না না
এখন দেখতে পাচ্ছ না?
না স্যার।
কি সমস্যা? এবার দেখতে পাচ্ছ?
না স্যার।
না স্যার।
এখনো পাচ্ছ না?
স্যার
আমি যখনই শেয়ার দিচ্ছি তখনই রিজিউম হচ্ছে কেন তাহলে? এবার কি দেখতে পাও?
জি স্যার।
জি স্যার।
Okay, so if we go for the microstructure, just in this section we will discuss about the cell or layers, different layers we are talking about. like middle lamella, primary all, and secondary all. This and secondary layer, and also that secondary layer that is detail. Then microfibrils and their structure, how that is formed, and what is microfibril. You know a bit. So after that, we will discuss about the orientation of the microfibril, how they are arranged. Then finally, we will not discuss about the ORT layer, but we have discussed earlier about the ORT layer, that is the innermost layer of the cell wall. And the composition of that layer, that still we don't know, because that depends on the fluid that flows through the lumen. So that is OT layer. Even in some cases, you will not get that OT layer because that is not the common. Because of that fluid flow, there is a thin layer. Sometime you will see, but not always. So generally, we say wood cell. It has three different layers: middle lamella, primary wall, and secondary layer that we are saying OT layer. And then cellular layers, that is reaction wood, that we will discuss in this section. So if you look at this slide, you will see this is a single cell, and you can see the cross section. So at the center there is lumen, and also we can see that there is cell wall. So if we see the cross section of the cell wall, there is different layers we can see, and there is black and white. Some portion is black and some portion is white. You can see it. So that dark portion that we are saying, black portion, that we are saying the macrofibril. And the inner part, that is the more detail about that portion, you will see that there is blue and parallel to each other. So that we are saying microfibril, and they are oriented vertically and parallel to each other, and that is formed from the glucose. So that is basically the monomer unit, that is glucose, and that glucose makes that polymer. And that polymer we are saying that is the cellulose chain, and that cellulose chain makes that polymer. So that's the structure, simple structure we can say. And if we see the different layers, then you will see the primary wall, that is the outer layer. এই তোমাদের ক্লাসে পার্থ দত্ত নামে কে বসছে?
জি স্যার আছে স্যার।
পার্থ দত্ত নামে কে? সে তার স্টুডেন্ট আইডি ইউজ করে না, আমি তাকে রিমুভ করে দিলাম। So the outer layer we can say that is the middle layer. Actually there is two layers: primary all and secondary all. So in between two cells there is a thin layer, so that we are saying middle lamella. Middle lamella, actually that is not the part, actually that is not part, but in general we say middle lamella, primary all and secondary all, because there is two cells, and in between two cells there is some gap. That gap is filled by some of the chemicals that we can say mostly lignin. So and when you separate the cell, so that part just goes with cells. So we'll say that is the middle lamella, then primary all, then secondary all. Then we'll say secondary all, that is again subdivided, divided into three different sub layers. So S1, S2 and S3. In case of secondary all, the outer part is S1, middle part is S2, and the inner part, that is S3. So after S3 there is a ORT layer. There is a thin layer that is associated with the S3. So that we are saying ORT layer. So if we look at the cross section of the cell, you will see the primary wall, that is the outer part, and in between two cells there is some gap. So when you separate the cells, that part just most the blackish portion that goes with the cell, we will say that is the middle lamella, part of the middle lamella. And if we can identify that middle lamella, then we will say true middle lamella. If we cannot identify the middle lamella when you separate the cell, then that goes with the primary wall. So you cannot from the primary all you cannot separate the that middle lamella. In that case we will say that is the combined middle lamella. So middle lamella combines with the primary all, we will say combined middle lamella. But if you can identify that middle lamella, okay, this is middle lamella, this is the primary all, in that case we will say that is the true middle lamella. So what about the cases? True middle lamella, primary all, then secondary. Secondary S1, S2, and S3. And the inner part, that is the lumen. So if you see the structure that we have discussed, just the most biggest part is the S2, that is 85% of the total cell all. So the rest of the 15%, if there is true middle lamella, it depends. But if that combines with middle lamella, primary all, then maybe that is 5, 6, 7%. Then S1 around 7%, S2 that is 85%, S3 that is thinner. So that is the percentage. That is not a millimeter. That we cannot say micrometer or nanometer. That is the percentage. So 85% is S2. So if you damage that 85%, that's you can damage all the cells. Then at the same time, if we again look at the structure, we will say we are talking about the earlier we are talking about the percentage. But if we now think about the thickness, so true middle lamella that is 0.2 to 1 micrometer. Remember that is the micrometer we are talking about. Primary all that is 0.1 to 0.2 micrometer, and S on 0.2 to 0.3 micrometer. However, that 85% that is the S2 layer that is on to 5 micrometer, and S3.1 micrometer. And you know lamella. So lamella it means layers. So layers that comes from the two, that is 30 to 150 different layers. So one layer, just like that. So that can be goes for 150 up to. But S1 4 to 6 only, S3 2 to 4 only, and primary or middle lamella and that you have already mentioned that I have already mentioned earlier to you is two layer that is around 85% of the total 85% of the total cell. And sometimes the primordial is difficult to separate from the middle lamella. Thus together with we can say that is the compound middle lamella. And you have earlier studied the reaction wood. So reaction wood that forms because of the leaning of the tree. So when a tree leans, you just imagine in the direction it leans, so that side the wood compressed, and in another side would expand. So that we are saying that type of wood, because of that reaction, because of that leaning, it has two different part. One part just compressed, another part is expanded. So that either compressed or expanded, we are saying that is the reaction wood. That means it doesn't have any formation like regular. So because of non-regular formation, because of that non-regular, because in other cases that should be similar, but in this special case, because of the tree is leaning in some portion compressed, so in that case we are saying compression wood. So in which portion that is compressed, we will say that is the compression wood. In another way, that is the expanded, we will say that is the tension wood, but that is not the regular wood. So its formation is not like the cell wall. Earlier we have studied that there should have middle lamella, then primary, then secondary. And in some cases we are saying that secondary is divided into S1, S2 and S3. However, that will not happen in case of tension and compression, because that is not the regular cell formation. So in case of normal wood, we are saying there should have in the secondary layer, there should have S1, S2 and S3. But in case of tension wood, you will see there is S1, then gelatinous layer, that's the G layer. So not there is no S2 and S3 layer. In some other cases, might be there is thinner S2 layer and then gelatinous layer. Or in some other cases, we can also say S1, S2, S3 at the center there is gelatinous. So, but in regular wood, you will never see the gelatinous layer. So you will see gelatinous layer only in the abnormal cases. So that is the reaction wood. Especially we will see there is a tension. And if we see the compression wood, so you will see also there is on gelatinous layer. S2 layer contains the helical cavities or check. So in case of S2 layer, you will see there is some breakage. So there is some cracks in the S2 layer. So it that, that means absence of S3 layer. In that cases, there will be no S3 layer. It should have round shape. However, there is some intercellular space, and S2 layer it contains some helical activities, and there also some cracks. So that is the structure, that is the microstructure and ultrastructure that we are discussing in this stage. So if you have any question, so you can ask me, anybody.
স্যার টেনশন উড
বলো।
কম্প্রেশন উডের ওই স্লাইডটাই স্যার কানেকশন একটু সমস্যা ছিল, যদি আরেকবার একটু বলতেন স্যার।
এটার ই তো তোমরা পাবা, স্লাইড তো তোমরা পাবা।
মানে
টেনশন
কথা
উড
শুনতে
এবং
পাইনি আসলে।
কম্প্রেশন উড এটা abnormal wood. এটা তো reaction wood. That reaction forms because of the leaning. The direction it leans, in that side there is some compression, and other side there is some tension. So because of that, it takes the regular formation in the cell wall. There is not regular formation. In case of tension, definitely there is some gelatinous layer. So that is along with the regular layers, or maybe it will miss. And in case of reaction, in case of compression wood, also there is no S2 layer. And if there is S2 layer, even though there is some cracks, so you will see that slide. You some of you will collect it from me, so you can get it. Okay.
জি স্যার।
Any other question from anybody?
স্যার জিলেটেনিয়াস লেয়ার কি শুধু স্যার অ্যাবনরমাল উডের ক্ষেত্রে দেখা যাবে?
অবশ্যই।
তাহলে স্যার যদি মানে কোনো গাছ যদি স্যার হেলে যায়, তাহলে তো ওখানে স্যার টেনশন কম্প্রেশন কাজ করবে। তাহলে স্যার ওই জিলেটেনিয়াস লেয়ার কি স্যার তাহলে কোনো গাছ পড়ার পরে কি ক্রিয়েট হয় ওটা?
আমি তোমার কথা বুঝি নাই
স্যার কোনো গাছ যদি স্যার টেনশন কম্প্রেশন হয়, তাহলে কি জিলেটেনিয়াস লেয়ার কি স্যার পরে ক্রিয়েট হয়?
পরে ক্রিয়েট হয় মানে কি? গাছ যখন লিনিং হবে তখন থেকে শুরু হবে। স্ট্রেট যখন হবে গাছ, তখন তো তোমার রিয়াকশন বা কম্প্রেশনের কোশ্চেন আসতেছে না। ইভেন একটা ট্রি যখন ব্রাঞ্চ আসতেছে একটা পার্ট, সো ব্রাঞ্চ তো লিন হয়, আইদার আপওয়ার্ড ডিরেকশন অথবা ডাউনওয়ার্ড ডিরেকশন। এটা অ্যানজিওস্পার্ম যদি হয় তাহলে ডাউনওয়ার্ড ডিরেকশন, যদি ব্রড লিফ হয় তাহলে আপওয়ার্ড ডিরেকশন। তো সেখানে তো একটা লিনিং কাজ করতেছে, এবং সেখানে এক সাইডে কম্প্রেশন হবে, যে সাইড লিন হচ্ছে এক সাইডে টেনশন হবে। যখনই এই ব্রাঞ্চটা তৈরি হচ্ছে, তখনই তার অ্যাবনর্মাল সেল গ্রো করা শুরু করতেছে, এবং সেই অ্যাবনর্মাল সেলকে আমরা বলছি রিয়াকশন।
স্যার বুঝতে পারছি।
আর কারো কোনো কোশ্চেন আছে?
স্যার ওই যে একটা ফিগার দেখাইছিলেন স্যার, ওইখানে মাইক্রোফাইব্রিল দিয়ে কি স্যার ম্যাক্রোফাইব্রিল তৈরি হয় নাকি দুটো আলাদা আলাদা?
আমরা ওটা যখন ডিসকাস করব তখন আমরা আসবো। আমরা মাইক্রোফিব্রিল আমরা এখন শুরুই করি নাই।
জি স্যার।
আমরা ওই পার্টে আসবো, ওই পার্ট আমরা ডিসকাস করব। আর কারো কোনো কোশ্চেন?
স্যার টেনশন বা কম্প্রেশনের জন্য স্যার সেল ক্যাভিটিটা মানে রাউন্ড শেপের কেন হয়ে যায়?
রাউন্ড শেপ তো আমরা যে কোনো লুমেনকে আমরা রাউন্ড শেপই বলবো। তো এটা যখন কম্প্রেস হবে তখন এটা খুবই স্মলার হবে। তো স্মলার জেনারেলি তো আমরা সেটা রাউন্ড শেপই ধরে নিব। যে কোনো লুমেনই তো আমরা রাউন্ড শেপই তো বলি। আমরা যখন ড্র করি তখন তো রাউন্ড শেপ করি, নাকি আমরা রেক্ট্যাঙ্গেল করি বা ট্রায়াঙ্গেল করি? তা তো করি না, করি? যে কোনো লুমেনই জেনারেলি রাউন্ড শেপ। সো এই রাউন্ড শেপটা স্মলার হবে যে কোনো ধরনের রিঅ্যাকশনের ক্ষেত্রে, রিঅ্যাকশন উডের ক্ষেত্রে। আর তার কোনো কোশ্চেন? তো আর কার কোনো কোশ্চেন আছে? সো আমি কি তাহলে পরের স্লাইড শুরু করব?
করেন।
সো এর আগের স্লাইডে আমরা সেলুলার লেয়ার্স নিয়ে আমরা দেখলাম, এবং সেলুলার লেয়ার্স কখন ভেরিয়েশন হবে, যখন there will have some reaction wood formation, and reaction wood forms because of the leaning. So cellular layers we have done. Then microfibrils, in this slide we will discuss about the microfibrils and their structure, how they are oriented in the cell wall, and outer layer we'll discuss a bit already, and we'll also discuss in this section a bit. So the elementary composition of the wood, that is carbon, hydrogen, oxygen, smaller portion of the nitrogen, smaller portion of the nitrogen. Also there is some minerals that we have discussed in the first classes. So around 49% that is carbon, only 6% that is hydrogen, and oxygen that is around 44%. So whatever the case is, that that hydrogen, oxygen, and carbon that makes the wood we are saying, and it has actually organic, inorganic part. So organic part, that is we are saying hollow cellulose, lignin, extractive, and the inorganic part that we are saying the different minerals. So that minerals we will get when there is complete combustion of the wood. Complete combustion, it means all the organic part will go, not like a complete combustion. We'll see after burning of the wood, sometimes we'll say we'll see the carbon, the black portion. So that will not say complete combustion. Complete combustion, it means all the organic part, not the partial. 100% organic part will go. So we are saying that is the complete combustion. So that after that complete combustion, we will get some portion even, because 100% you cannot burn, maybe 99.9% you can burn. So rest of the part, that is the minerals. So that is the inorganic part. So wood, it has organic, it has inorganic part. Organic part composed of hollow cellulose, lignin, and extractive. So in our case, we will discuss about all these things: hollow cellulose, lignin, and extractive. So hollow cellulose, it has also 3 different compounds. The first compound is cellulose, the second one is hemicellulose, and then pectic substances. Pectic substances, that is a very smaller portion. So generally we don't discuss a bit, but that is also a carbohydrate. But mostly the main component of the wood, that is cellulose, hemicellulose, and lignin. So cellulose, hemicellulose, it composed of hollow cellulose, and in other cases the lignin. So that is non-carbohydrate compound, and extractive, smaller portion. However, cellulose, hemicellulose, and lignin, that are the structural component. Extractive, that is the non-structural component. So now look at the classification. Wood, first we are saying it has organic, it has inorganic. Organic, some portion is structural compound, some portion is non-structural compound. Non-structural compound, that is the extractive. Structural compound, then we will say it has hollow cellulose, it has lignin. Then hollow cellulose, again we are dividing into cellulose, hemicellulose, and pectic substances. So wood is composed of so many different things. We will say cellulose, we will say hemicellulose, we will say pectic substances, we will say lignin, we will say extractive, we will say inorganic or ash content. So it composed of many different compounds. So that is a biocomposite. So is it clear the biocomposite why we are saying wood? Because it composed of many different compounds. So the organic component of the wood, that CaSO, that makes cellulose, hemicellulose, lignin, a smaller portion of the pectic substances, and also the extra active. Then we are saying glucose. So the first compound we are talking about, that is a cellulose. So cellulose, that means it forms from the glucose. I think you know the glucose, because some of you, when you are sick, or especially the players, when they play football or cricket, they need glucose. So it means it gives you the instant energy, and generally you say C6H12O6. But if we look at the structure, you will see the first figure, that is the structure of the glucose, and the first carbon that starts from the right side and then goes bottom, first, second, third, fourth, fifth, sixth. Remember that in that six, uh, in that connection, there is the after fifth there is oxygen. So the ring, there is six carbon, but that six carbon never makes that ring. In the ring, if we think about the ring, in the ring there is five carbon and on oxygen. So we are saying that is a pyranose. But when we write just the sixth carbon that is connected with the fifth on, and the sixth position, so that is filled by the oxygen. And that is the glucose structure. That is very important for you, because in all the cases we'll discuss about that glucose structure. So that glucose, when comes together, when joined together, so it releases on H2O. So we are saying that is a condensation. That if you can remember, we have discussed in the first class condensation and hydrolysis. So when that is on monomer of the cellulose, because glucose unit come join together and it makes the cellulose. So that glucose unit, when joined with other glucose unit, so it release on H2O, and we are saying that is the it forms cellulose. So that sugar monomer, if you see, that is the hemicellulose. So we are just discussing a bit about the cellulose, hemicellulose, but because this makes the microfibril, so we are uh, discussing a bit about that. So that sugar monomer, that sugar monomer, that sugar monomer, that are hemicellulose. In case of cellulose, you will see only glucose is there, but in case of hemicellulose, there is not a single component. It has many different components. Maybe that is glucose itself, maybe mannose, maybe xylose, maybe arabinose, maybe galactose. So many different types of sugar monomer that makes the polymer, and we are saying hemicellulose. So in case of cellulose, only on monomer. In case of hemicellulose, many different monomers. So if we look at the properties, degree of polymerization in case of cellulose, that is 8,000 to 10,000. It means 8 to 10,000 glucose unit is there, but hemicellulose just around 150. Cellulose, that is not soluble in 17.5% sodium hydroxide. That is stable, but hemicellulose, it will dissolve. And some of the pectic substances that we have mentioned earlier, a smaller amount, that is also a carbohydrate. So that carbohydrate, that is similar to hemicellulose, that might have different compounds, and that compound dissolve when you use 17.5% sodium hydroxide solution. So three different terminology now we will see: alpha cellulose, beta cellulose, and gamma cellulose. Alpha cellulose, so if you add 17.5% sodium hydroxide solution with the cellulose, so you will see some portion is not dissolving and a portion that dissolved. So the portion not dissolved, we will say that is the alpha cellulose. That is the more stronger cellulose. And the portion it dissolved, we will say others. Then we are adding 17.5% sodium hydroxide. It means alkaline. So make it neutral condition. Add more water, so it turns into our some of the acid you add, so it comes into neutral condition. When it comes in the neutral condition, you will see there is some precipitation at the bottom. So that precipitate part, that is also cellulose, we will say that is the beta cellulose. And a portion, it will not precipitate even after neutralization of that solution, we will say that is the gamma cellulose. So we are talking about the cellulose, and in cellulose we see three different types. One is alpha, one is beta, one is gamma. If that is alpha, it will not dissolve in 17.5%, and so you will just get it from the solution. Then in the solution, if you make it, if you neutralize that, so you will see some precipitation, that we are saying beta, and finally we will say that is the gamma. So that we have the carbohydrate, and in case of lignin, definitely that is not carbohydrate, so that is the aromatic in nature. And uh, the first one, that is the linear structure, that is just only one monomer is there, that's cellulose, that is the glucose. So glucose connected and it makes a long chain. But in case of hemicellulose, that is more than one, there may be 2, 3, 4, 5, 6 different monomer is there. We can say glucose, galactose, xylose, arabinose, mannose, many different monomers is there, and that monomer connected together, so it has some side branches. But in case of lignin, it has also different compound comes together, and it makes three-dimensional structure. So in all side, so one is side branches, two-dimensional, one is linear, then hemicellulose two-dimensional, and lignin, that is three-dimensional structure. And mostly that is the not mostly, that is a polymer of phenyl propane units. So the main component, that is cellulose, hemicellulose, that is carbohydrate, that is sugar. So and non-sugar component is the lignin. So extractive, so many different types of extractive. So we'll discuss when we will discuss the extractive section. So this is very complicated because 4,000, 5,000, so many different chemicals is in wood. So we are not discussing in this section in detail. So many different types, that may be polyphenol, that may be oleoresin, that may be gums, fats, esters, so many different types of extractives are there. So some of the major compounds that we will discuss in this extractive part. And the inorganic part, that is, we are saying the minerals tree absorb during its lifetime for its growth and some other things. So that is the ash content, and that is calcium, potassium, and magnesium. So mostly 70%, but there is some there is other minerals also. But if you just talk about the calcium, potassium, and magnesium, it will be 70% of the total minerals, total ash. Mostly that is calcium, potassium, and magnesium. And very smaller portion of the nitrogenous compound, because without nitrogen we cannot think for the life. So definitely in the tree it has some nitrogen. So now if you see the structure again, because we have some basic idea, see where they are distributed, because that comes with the structure. So sometimes we are saying that sometimes we can identify the middle lamella, sometimes we cannot identify the middle lamella. When we can identify, we will say that is a true middle lamella. When cannot identify and goes with the primary all, we will say combined middle lamella. Then secondary all is subdivided into S1, S2, and S3, and at the center there is lumen. So three different compounds we have discussed so far. The most important, that is cellulose, hemicellulose, and lignin. So if you look at the right side, cell topochemistry. Topochemistry, it means the distribution of the chemicals in different layers. So in x-axis, you will see the compound middle lamella at the beginning, then S1, then S2, and S3. S2 is the 85% of the cell all, so that is the biggest area. Then S3 is smaller, S1 is also smaller, and compound middle lamella, that is also. So here we didn't divide into true middle lamella and primary all, just that is combinedly we are saying compound middle lamella. And you will see most of the portion in S2, that is cellulose. Then smaller, not very smaller portion is lignin, But even so, we can say carbohydrate is more than or around 90% is carbohydrate in case of S2 layer. In case of S1 layer, that is also around 70% is carbohydrate, and S3 layer, that is also 90% is around S3 layer. So we can say secondary layer is mostly composed of carbohydrate. And if you see at the compound middle lamella, that includes primary wall and true middle lamella, you will see that is mostly lignin. 70% is lignin. So now we can conclude from here that the true middle lamella and primary wall, that is mostly composed of lignin, and the secondary wall, that may be S1, that may be S2, and that may be S3, that is composed of carbohydrate. Among that carbohydrate, so the highest amount of cellulose that is present in the S2 layer, then in S1 and S3 that is little lower, but hemicellulose portion that is higher in case of in both cases. So that are the different properties we have discussed earlier. So in middle lamella, that is mostly lignin. In case of primary wall, that is also mostly lignin, but so that combines the compound middle lamella. Secondary wall, that is mostly carbohydrate, that is cellulose and hemicellulose. And outer layer, the composition we cannot say, because that depends on which type of fluid that flows through the lumen. And when that dries, so that type of composition we will get, but not always you will see that there is outer layers. And how we will identify the different compounds in the cell wall. So because of to identify that, there is different mechanism uh, and some of them are chromatography, spectroscopy, chemical analysis, ultraviolet and fluorescence microscopy. So many different types of image we can get it. And after getting that image, we can identify which layers is there. So there is some Victorian blue. If you add with that cell wall, you will see some portion changes, some portion don't changes. So depending on that, we can say this portion is lignin, this portion is cellulose or carbohydrate. So that is we are saying staining. Staining, it means changes of the color. So depending on the cellulose compound, sometimes it turns into red, sometimes turns into blue. So that we can use. So we are saying that is the staining. That is the most common mechanism. So what you will do, you will make a thin layer, thin slice of that material of that cellulose, and you will put it in the color that we can say Victorian blue or some other stains also there, and then you will see in the microscope. You take the picture and you will see some portion is reddish, some portion is bluish. So depending on that, we can say that portion is there. Then compression wood and also tension wood that we have discussed earlier. In case of compression, in case of tension wood, some of the sub layers are missing. In case of compression wood, also some layers are missing. But in case of tension wood, definitely there should have gelatinous layer. In compression wood, you will see the cracks that will happen in the S2 layer. And also in the lumen, lumen that we are saying the free space, but in some cases you have also studied earlier that portion. So that I think you have some idea about the tylosis. So tylosis, that is the outgrowth. That means there is the excess growth of the parenchyma, the outgrowth of the parenchyma. So outgrowth, it means all the cells are compact. So definitely the outgrowth that come out from the parenchyma cell. So how is the space? Space definitely is the lumen is the space. There is no other space in the inside the wood. So that parenchyma comes in the lumen and it grows over there. So we are saying that is the tylosis. So the function of the tylosis, it means it comes in the lumen. It means it blocks the lumen. So in all the species that will not happen, especially in the teak. So if we look at the microscope about the lumen, we should see from one side to another side. That should be. However, because of the tylosis, the movement of the chemicals that is restricted because of the tylosis. So because that tylosis comes in the lumen and it fills the lumen, so chemicals or liquid cannot move. So some of the species it forms, that is a natural phenomena, that is not the abnormal case. That is a natural phenomena and that comes from the parenchyma. So in case of definition, we will see tylosis is the outgrowth of the parenchyma cells comes in the cell lumen. So we can also identify that. So that are the things. So in the next class, we will discuss about the structure of the microfibril. So if you have any question, uh, anybody, you can ask me.
স্যার ওই আলফা বিটা আর গামা ওই সেলুলোজের ওই ক্লাসিফিকেশনটা কিভাবে মানে আলাদা করা হয় স্যার সলিউবিলিটি দিয়ে ওইটা বুঝতে পারিনি।
So if you have cellulose, you have collected the cellulose from the wood. So add that cellulose in 17.5% sodium hydroxide solution. You are putting your collected cellulose into the 17.5% sodium hydroxide solution. You will see some portion dissolve, some portion will not dissolve. And you are adding 17.5% sodium hydroxide. It means alkaline solution you are adding, higher alkaline solution, stronger alkaline solution you are adding. So when you add that stronger alkaline solution, so some portion dissolve, some portion don't dissolve. So the portion which didn't dissolve, you will see that is the alpha cellulose. Now you have the solution and nothing is there, you cannot see anything, but that is alkaline solution. So make it neutral. Neutral, it means the pH was higher, now makes it 7, neutral solution. pH that should go 7. So that pH, when it comes, you will see there is some precipitation at the bottom, there is something deposited. So that is the beta cellulose, and still a portion that is in the solution, and you will never isolate that portion, that we are saying gamma cellulose. So cellulose, depending on the solubility in the alkaline solution, we will see there is alpha cellulose, there is beta cellulose, and there is gamma cellulose. Is it clear?
ইয়েস স্যার।
Okay, any other question?
স্যার সেল অল টপোকেমিস্ট্রির যে গ্রাফটা ছিল ওইটা ভালোভাবে বুঝতে পারিনি।
That is so easy. So in the x-axis you have different layers, that is primariole, middle lamella, primariole, then S1, S2 and S3 sublayer. So and in the y-axis there is cellulose, hemicellulose and lignin. So we can see that in most of the cases the secondary layer, that may be S1, S2, S3, there is mostly carbohydrate, smaller amount lignin. Whereas in the primariole and middle lamella, there is mostly lignin, less carbohydrate. So that is the topochemistry where that is distributed. Even in the secondary layer, the S2 layer, that is 85% of the cell wall, and that is mostly cellulose. Then less another portion is hemicellulose, and then very smaller portion is lignin. So we can say that in the secondary layer, less lignin, in the middle lamella or primariole, less carbohydrate. Okay.
জি স্যার।
Any other question?
স্যার সেলুলোজের নিচে দেওয়া ছিল যে বেটা 1,4 গ্লাইকোসাইড বন্ড, ওইটা বুঝি নাই স্যার।
It when we discuss the cellulose, so that we will discuss the details. We are just discussing a just basic idea. Cellulose, it has 6 carbon, but that 6 carbon will not make the 600 ring. So that we will discuss the details, how it form. This is just to know there is something that is cellulose, and that cellulose is formed from the glucose, and there is 10,000 glucose unit. That you just the basic because when we are going to discuss the topochemistry and some other part, even like the structure of the microfibril, then we need it. So we are discussing very smaller portion. The details in the other chapters that we will discuss. Okay.
জি স্যার।
So any other question from anybody? Any other question from anybody?
স্যার টাইলোসিস ফর্মটা যদি স্যার আরেকটু বলতেন, স্যার নেটওয়ার্কের প্রবলেমের জন্য ভালো কথা বুঝতে পারছি না।
So tylosis, that is the outgrowth of the parenchyma cells. So outgrowth, it means something coming out from the cells. So there is no space actually in the wood other than the cell lumen. So that outgrowth comes in the lumen. So in general, not in general, we say what is tylosis? Tylosis is the outgrowth of the parenchyma cells comes in the lumen, and when it comes in the lumen, then it blocks the lumen. So fluid, it cannot flow. So that fluid cannot flow because the lumen that is filled with the tylosis. So if you want to go for the preservation on impregnating some of the chemicals into the wood, so you have the lumen is the space, but you cannot impregnate it because that space is filled by the tylosis. So tylosis is the outgrowth of the parenchyma cells in the lumen. Okay.
জি স্যার।
Any other question from anybody? Any other question? No.
স্যার স্টেনিং
কি জিনিস?
স্টেইনিং
Staining is the coloring. So you are adding different colors so that carbohydrate reacting in a way, lignin is reacting in different ways. So that is called staining.